coupling. Okay, so the bibliographic coupling also is a kind of a method to evaluate the relation between two papers. Now this is the other way, in the sense that you publish a paper and you're citing some references in a paper, right? So let us take two papers I and J that are having some references in the paper. So what we are trying to find out is the number of common references they have in their bibliography. So bibliography is also called the references. Okay, it's a more formal name for calling references. So they'll tell what is your bibliography, what is the when you publish a paper you should have a bibliographic section, that means the reference section. So you try to evaluate the similarity between two papers I and J based on their number of common references. So two papers I and J are considered to be more similar to each other if they have more common references. Okay, and you think about this is something we could measure at the time of publication itself. So I publish a paper right now, and there was another paper that was published 10 years back. I could evaluate the similarity of these two papers by just finding the number of common references between these two papers. It is because the common references should have been also published before the latest of the two I and J were published, right? Because if I have to cite a paper, that paper should have been published earlier than my paper. So all the papers that I and J are citing should have been published earlier than I and J, or like whatever I is citing should be published before I, whatever J is citing should be published before I, isn't it? So with this bibliographic coupling measure, I could evaluate the similarity between two papers at the time after both the papers get published, right? We don't have to wait for time to pass, because the cited papers that were cited should have been also published before the corresponding papers. And it's also a static measure, in the sense that once I publish once I and J are published, we can find their similarity based on this bibliographic coupling, the common references right away, and it's not going to change with time, because we're not going to add some new references after a paper gets published. That's not going to be possible. So it's a static measure, and it can be evaluated at the time of publication of the paper. So it can be basically can say you can evaluate this measure after the two papers I and J are published. Is that clear? So you see the difference between this and co-citation coupling. For co-citation coupling, it takes time for the number of papers that cite both I and J to increase with time. Okay, so this is the other way. So co-citation coupling means the third paper, the other papers should be citing I and J, and that will take time. As more papers get published in that area, they will be citing I and J together. So the similarity of two papers I and J cannot be assessed right away after they are published. It goes with time. So it's a dynamic measure that changes with time and cannot be calculated right away after the publication of the two papers. Whereas bibliographic coupling is a static measure. It doesn't change with time, and it can be computed right after the publication. That's the major difference. So let us now calculate this measure. So let us use the notation B to indicate the bibliographic coupling matrix that we are going to find out. An entry for papers I and J, that means row I column J, will be 1 if again for a third paper K, if both I is citing paper K as well as J is citing paper K, right? So if AIK is a 1 as well as AJK is a 1, then for a particular vertex K, the entry Bij will be 1. And we want to find all such K equals 1 to n, all those vertices that are cited by both I and J. So this is the matrix we want to find out. For all K running from 1 to n, AIK and AJK, both these entries should be 1, so the product can be 1. Now again, in order to do this as a matrix multiplication, right away the column index and row index doesn't match the two matrices. So we will take a transpose of this with k, because remember we are always doing the transpose so that the k matches. So we do a transpose of second matrix, so the k in the index in the, which is a column index in the first matrix, will match with the k as a row index in the second matrix. So basically the bibliographic coupling is A times A transpose. Am I recording this? Okay. So it's A times A transpose. So that's all we need to know. So given a directed graph, we can come up with this adjacency matrix and transpose. We know that from the earlier module, from the earlier topic. So now A times A transpose. So just multiply A with its transpose. So that is going to get us this product matrix. Again, the rule for matrix multiplication is still used here. To get an entry for cell say 4, 6, we have to multiply row 4 with column 6. So row 4 is this, column 6 is this. So 0 times 1 plus 0 times 0 plus 1 times 1 plus 0 times 0 plus 1 times 1 plus 0 times 0. So that's going to be 2. So that is what is this. So what this means is 4 and 6 are citing two papers in common. So let's verify that. 4 is citing 3 and 5, so two papers. 6 is also citing 3 and 5, even though 6 is citing 1, but 4 is not citing 1. So there are only two papers that are being cited by both 4 and 6. So that is the bibliographic coupling index of 4 and 6. So it's also going to be symmetric matrix. If the entry for 4, 6 is 2 in the product matrix, entry 6, 4 is also going to be 2, because 4 and 6 are citing two papers, the same as 6 and 4 are citing two papers. So it's not going to be different. So it's a symmetric matrix, and the diagonal is also going to have some values. So let us interpret that. So the diagonal, let us say for example 4 is having an entry 2. So that means what? 4 and 4 are citing two papers, right? So that's basically indicating the number of papers cited by 4. Okay. Let us look at 6. It says 3 for 6 and 6. So that means 6 is citing 3 papers. So 6 is citing 1, 3 and 5. So that's what the number indicates. Okay. So you see the entries in the bibliographic coupling matrix are going to be different from the entries in the co-citation coupling matrix. For example, 6 does not have any entry in its diagonal. That's basically because in the graph nobody is citing 6. So for co-citation coupling, some papers should be citing, some other paper should be citing this vertex, and nobody is citing 6. So and that probably means 6 is a newly written paper or a paper that doesn't have much value, nobody is citing out there in the literature. Okay. Whereas bibliographic coupling index for 6 is 3, that's basically because it's the number of references it is citing. So between the two, you could think which one I should really use to evaluate the merit or kind of the value of a paper. Okay. And can anyone say which one we should use? So co-citation or bibliographic, or both, or kind of equally can be equally considered for evaluating the merit of a paper, the value of a paper? Any answer? No? So as I just explained, based on paper 6, the entry for paper 6 is 0 in the co-citation coupling matrix in the diagonal. That's because nobody is citing paper 6, right? It could be that even 6 has been published much earlier, but if it has not been cited since its publication time, it means it doesn't have much value, so that others are citing it. Okay. Whereas if you look at the diagonal entry for 6, it says 3. This number 3 doesn't indicate anything about 6, right? In the sense that how valuable is the content in paper 6. It's not a measure of that. It's a measure of simply how many papers that 6 is citing. I could cite 100 papers in my paper, but if my paper is not cited by somebody else, my paper doesn't have much added value to the literature. I could publish a paper that cites several other papers out there, but it doesn't add much value to the literature if nobody else is citing my paper, even after some time. We have to wait for some time, like the post citation thing I mentioned. But even after waiting for some time, if my paper is not being cited by other papers, that means nobody is having a look at my paper and citing that paper. So the co-citation coupling is more valuable in the sense that it's more useful to evaluate the merit of a paper compared to the bibliographic coupling. The bibliographic coupling is used mainly to find out a static measure of the similarity between two papers. Okay, and based on the number of common references they have. So if two papers have a lot of common references, that means they probably talk about almost the same topic. That's what the bibliographic coupling is telling. As a co-citation coupling is telling that information also. If several papers are commonly citing a paper, yes, there should be common between the two papers I and J. So with co-citation coupling, you also have a way of evaluating the similarity between two papers. But in addition to that, the more important, it is capturing the growth of a paper with time and also the growth of an area with time. The growth of a particular paper means if the entry for the diagonal keeps increasing, that means more papers are starting to cite that particular paper, as well as if any entry I and J in general is increasing, means whatever the common area or the common topic that I and J are talking about, that topic is gaining more popularity with time, that more papers are citing that paper and more authors are working on that topic. That's what that captures. And bibliographic coupling doesn't capture all these things. Okay, so co-citation coupling matrix is more valuable, even though it takes time to really capture all these things. Eventually it will measure all these things. And bibliographic, even though you can get quickly some numbers, those numbers don't really add much value to the literature other than just evaluating the similarity between two papers with respect to the topic they're talking about. Okay, any question? Alright, so next time what we'll do is we will use similar matrix multiplication approach and analyze this bipartite graph thing. Okay, so we might have seen that in some earlier class, data structures, but so we'll build on top of it what we have seen on bipartite graph. And the idea we are going to use is very similar to what we did for co-citation bibliographic coupling with respect to the matrix multiplication and trying to build a graph. And then we're also going to look at the breadth first search algorithm and move on. We'll try to finish the module next class, okay, so that we can move on to the next module. Alright, so I posted the syllabus in Canvas. It's also there in the course website. Now there's a link for this course. Okay, so the course website has everything right now. I'll post the exams and assignments as we move on. So after finish this module, I should be able to post it. So if you look at the course syllabus, we are going to have 4 exams. Yeah, 4 exams. 4 exams and 2 or 3 assignments. Okay. So the first exam I have planned on September 24th as a due date. So I should be posting sometime in the next 1 or 2 weeks. It should be there. And each one should have a graph to work on and answer the questions. Now the videos, as I was mentioning, some people during the break, it seems somehow the Canvas, my other classes it is working, but for this class they had disabled these pages. So I used to post, I have actually posted all the videos so far, basically the previous class videos in YouTube, and I have posted a link here, so you should be able to see this, I thought, but unfortunately it's not. So I'm going to move all these links to under the modules section, which you should be able to see, because you should be able to download the slides now. So similarly, I'll post probably under the module itself, I'll post the links. I'll post a separate page that has all the links, that will be easier to follow. Okay, so I'll do that for each module as we proceed. Right? Any questions? So if not, we can meet next week. Next Thursday at 6 p.m. Have a nice weekend.
Have a nice weekend too.
You too. Thank you, Ingrid. Thank you all. Okay, see you next week. Okay, bye-bye.